Okay, we're going to go ahead and start our third day of graphing the sine and cosine functions, the trig functions. Today I'm introducing something fairly simple, hopefully. We're going to talk about an x-axis reflection. So we know an x-axis reflection, if you write up here, or if you read up here, occurs when all the y values of a function become the opposite, so they're all switched. So if a y value is positive, okay, it drops down to becoming negative. If it's negative, it becomes positive. And what that does is it flips it over the x-axis when you make them the opposite. So in the trig functions that we've been talking about, okay, if you think about it, when you fill in for a number for x or something for x, you get out a y answer. So if you put a negative all the way in the front of the function, okay, that's going to flip all of your y answers. It's going to make them the opposite. So if there's a negative, okay, in front of a, the graph's going to have an x-axis reflection. It's important to remember, though, I wrote at the bottom in green, that if there's a negative a in the front, okay, the amplitude is still positive. It's the absolute value because the distance between the middle and the highest and lowest point does not change just because there's a negative out front. So we're just going to do one example today, and I think you'll get the idea of how to graph a reflection. Okay, so what I want you to do, this is the only example we're going to do, go ahead and write this down. Go ahead and do this like yesterday or whatever day you were here last, but ignore the negative sign out front. Go ahead and graph it as if it was just positive 7 sine 4/5 x plus pi over 3. Because that's what you're going to do essentially. You're going to create a graph as if it was positive, and then we'll reflect that answer last. So go ahead and try to fill these in. You can pause it and then check, see if you have the same answers that I do. All right, I'm going to start with period first. Period we know is 2 pi divided by b. B in this case is 4/5. So I told you an easy way to do period, if you have a fraction, okay, 4b, is to take 2 pi and multiply it by the reciprocal of the fraction, which is 5/4. If you do that and you reduce, you end up getting 5 pi over 2. Okay, so I'm going to go ahead and fill that in for period. Okay, your amplitude in this problem is the absolute value of a, okay, which would be positive 7. So I'm going to write that in. Your starting x value, if you remember, you set the bx plus or minus c equal to 0. So up here, 4/5 x plus pi over 3, if I set that equal to 0 and solve for x, I should get my new starting point. Okay, so if I do that, what I'm going to do is go ahead and move pi over 3 to the other side, so it becomes negative. And then I'm going to multiply both sides by 5 over 4. Okay, that will cancel that out. So you find out the starting point is actually negative 5 pi over 12. Okay, so I'm going to go ahead and fill that back in over here. Erase this, give myself a little room. Your ending point, if you know where a function starts and you know how far it travels, you can add those together and then you figure out where it ends. Should kind of be common sense on that. So this function we just figured out starts with the next value of negative 5 pi over 12. It travels a distance, its period, of 5 pi over 2. And so if you do a common denominator and add, let's see, this would be 30 over 12. So if you add, you should get positive 25 pi over 12. And that's where it would end at. So 25 pi over 12. Once you have that information, you can go ahead and start graphing it. Okay, so I'm going to start graphing it now. First thing I need to do is actually put a y-axis. Okay, since I know the x values where it starts and ends, I can kind of guess where the y-axis will go. Starting at a negative value that's small, okay, somewhat small, it's ending with an x value that's fairly big. So that means most of my graph will be on the right side of the y-axis. Okay, so I'm going to go ahead and put my y-axis somewhat to the left. I know this graph is starting at an x value of negative 5 pi over 12. Okay, I know it's going to end with an x value of 25 pi over 12. There's still 5 main points on all these graphs, so I'm going to divide that in half, and each of those in half, okay, to kind of get an idea where those points are going to be. And then if you remember to figure out what you're counting by, you take the distance that the graph travels, which is the period, 5 pi over 2, and you divide by 4. Okay, which is also the same as multiplying by 1/4. So to get from one to the next, I am adding 5 pi over 8. I'm adding 5 pi over 8. To make it a little bit easier, I'm going to change that to a common denominator with what my original starting x value is, okay, negative 5 pi over 12. I'm going to rewrite it with a denominator of 24 to make it a little bit easier. So that should be 15 pi over 24. I'm going to change negative 5 pi over 12 to something with 24 by multiplying the top and bottom by 2. So negative 10 pi over 24. Okay, just to make it a little bit easier. So when I add 15 pi over 24 each time, it makes it easy. So when I add it the first time, I get 5 pi over 24. If I add it again, I get 20 pi over 24. If I add it again, I get 35 pi over 24. And if I add it again, I would get 50 over 24 pi, which reduces down to my last x value, 25 pi over 12. Okay, once I know that, I'm going to go ahead and put the amplitude on. So this graph should go up to 7 and down to negative 7. Okay, so if I graph it as is right now, as if there's a positive 7 in front of sine, all I need to know is my pattern for sine. Sine goes middle for the first point, high for the second, middle for the third, low for the fourth, and middle for the fifth. Okay, so the sine graph, okay, would look like that if there was no reflection. Okay? A reflection is real easy to graph. Since I have a negative out front, okay, I have a reflection. So what that means is every y value that's positive will now become negative. Okay, so I can make this real easy. I'm going to do it with the 5 main points. I'm going to switch the positives to negatives. So right here, the negative value of 0 is still 0. Okay, my second point was 7. Now it becomes negative 7. So the high went to the low. My third one, the opposite of 0, is still 0. My fourth point was originally a y value negative 7. Now it's positive 7, because you had a negative out front. And then your last one stays 0. So if I connect those, I can see what the reflection looks like for my final graph. Okay, and I'm just going to label it. Okay, but you can always do that. You can always draw as if there wasn't a reflection and then draw the reflection after. To answer my last few questions, okay, my horizontal shift, this originally started at 0. Now it's starting at negative 10 pi over 24. So it shifted to the left, 10 pi over 24. Your range, you still have y values between negative 7 and 7. So my y values are between negative 7 and 7. And an x-axis reflection, okay, yes, we had one because we had a negative out